All right, let's get into it. Today, we're going to talk about building a fully autonomous AI agent. I mean, think about it, a bot that can actually go out and find new business leads for you. But, this story has a pretty big twist. It's not just about how to build a brilliant bot. It's about what happens when that bot slams headfirst into the unforgiving reality of deployment. Just picture this for a minute. What if you could give an AI a simple goal like, hey, find me some tech companies that could use our product? And it just goes. It starts browsing websites, it actually understands their business, and then it comes back with a perfect list of qualified leads. I know it sounds like science fiction, but that's the incredible promise of AI agents right now.
Okay, but here's the catch, right? If you've ever tried to automate anything on the web, you know the pain. Those traditional scripts, they use these things called CSS selectors to find buttons in text. And the very second a website pushes a tiny layout change, poof, your whole automation just shatters into a million pieces. It is so brittle. So the real question is, how do you build an agent that can actually survive the chaos of the modern web?
Well, the solution is to think about the architecture in a new way, basically by giving our agent a separate brain and hands. It sounds simple, but this separation is the absolute key to building resilient AI that doesn't just work in a sterile lab, but can actually thrive out in the wild. So, this separation of concerns is it's everything. On one side, you have the brain. It's a framework called Mastra. This is the strategist. It's written in TypeScript, it plans the high-level mission, and it uses large language models to make the big decisions. Then, on the other side, you have the hands, an SDK called Stagehand. Now, Stagehand is what actually gets its hands dirty in the browser. But here's the magic. Instead of using those fragile selectors, it uses AI to understand the page, just like a person would. You can literally tell it, click the sign-in button, and it just figures it out. That's what makes it so tough. All right, so enough theory. Let's see how this actually works on a real mission. We're going to watch this brain and these hands work together to find a qualified lead, and it all happens in a really simple but super powerful three-step process. So first up, the agent navigates to a company's website and just sucks in all the text. Step two, and this is the really smart part, its brain analyzes that content to decide if this company is even a good fit in the first place. This saves a ton of time and resources. And only if it's relevant does the agent move on to step three, hunting for that primary contact info. It's all about being efficient and targeted. Now, check this out, because what's so cool about this quote is that this isn't just some instruction we're telling the agent. This is actual text from the code itself. It's a description inside something called a ZOD schema. By explicitly telling the model to return null if it doesn't find an email, we keep it from hallucinating and just making one up. It's a brilliant little bit of prompt engineering that makes the whole thing way more accurate. So at this point, we've got a perfectly designed agent, right? The brain is smart, the hands are resilient, we are ready to go. We deploy it to the cloud using Vercel, and then we hit a wall. A big one. The deployment nightmare is about to begin. 60 seconds. That's it. That is the absolute maximum amount of time a standard serverless function on Vercel can run. But our agent's job, it's completely unpredictable. A slow website, a random CAPTCHA, any of that could easily take way longer. A single Vercel function is just fundamentally the wrong tool for a long-running job. Our brilliant little bot is destined to time out and fail before it even gets started. So now what? This forces us to make a really critical architectural choice. We have to pick a deployment path that can actually handle what our agent needs to do. So let's look at a little showdown of the different strategies available. Okay, so on the one hand, you could attempt this really complex workaround. You'd have to chop your agent's task into these tiny little pieces and then use a database like Supabase to pass the state from one piece to the next. Trust me, it's brittle, it's slow, and trying to debug it is an absolute nightmare. Or you could use an elegant add-on like Ingest. It basically acts as an orchestrator, automatically handling all the timeouts and the state for you. Your code stays simple, and the whole thing just works. The other option, of course, is to just leave the serverless world behind for this particular job. And this chart really shows you the cost of that choice. If you go with infrastructure as a service, or IaaS, where you're basically just renting a server and have to manage everything yourself, look at that management overhead. It's through the roof. Now compare that to platform as a service, or PaaS, where a provider handles all the underlying stuff for you. The overhead is super low, and that serverless chained approach we just talked about, well, it lands you right in the middle, giving you a high management burden. Kind of the worst of both worlds. And this table just lays it all out perfectly. You can really see the trade-offs.
That Vercel plus Superbase workaround, super complex, high overhead. Vercel plus Ingest, easy to deploy, low overhead. Then you've got the PaaS options, like Render and Fly.io. They have very low overhead and a predictable, pretty cheap monthly cost. We're talking like $7 for Render. And finally, there's the IaaS route with DigitalOcean. Sure, it looks cheap up front, but you end up paying for it big time with your own time and effort. Okay, so after looking at all these options, what's the final blueprint? What is the right move here? Let's lay out a super clear roadmap that can take us all the way from our first version, the MVP, to a massive, scalable system. So here it is, the final verdict. For your MVP, your first version, stick with Vercel and just add Ingest. It's by far the fastest way to solve that timeout problem without adding a bunch of crazy complexity. But, and this is key, as you start to scale up and the number of jobs explodes, the plan is to migrate that agent worker over to a PaaS like Render. That's going to give you predictable pricing and an environment that is purpose-built for this exact kind of work.
You know, if there is one core lesson to pull from this whole journey, it is this. You have to match your task to the platform's paradigm. The reason we ran into trouble was because we were trying to shove a long-running, stateful task onto a platform designed for short-lived, stateless functions. The best solution isn't to fight the platform, it's to choose the right platform for the job.
And hey, let's not forget the big lesson from the agent's design itself. That elegant split between Mastra and Stagehand. That is such a powerful pattern for any kind of automation. Separate your concerns. Let the brain focus on the high-level strategy, and let the hands deal with the messy, low-level actions. So all of this leaves us with a final thought to chew on. As these AI agents get more and more powerful, what's actually going to be more important? The agents themselves, or the underlying infrastructure and platforms that are powerful and flexible enough to actually run them? It's a question I think we're all going to be answering very, very soon.